Autoregressive models like Gemini, GPT, and Claude's are fundamentally constrained by the inherent latency of serial decoding. Now, diffusion solved this by parallel generation of the entire sequence and can give you up to 10 times faster inference. An example of this is Gemini diffusion that I covered in my videos last year. I had early access to this model. Another example is seed diffusion, which is a diffusion-powered large language model from ByteDance. Now, both of these models shows superior inference speed of diffusion-based large language models compared to autoregressive models. However, both of them were research previews. One of the very first commercial offering of a diffusion-powered large language model was from a company called Inception Labs last year, where they showed that you can get faster responses compared to their autoregressive counterparts. Last year, they released Mercury and Mercury Coder. Now, they're releasing a second version called Mercury 2, but this time it's a thinking or reasoning model. They give me early access to the model, and the technology is pretty impressive, especially when it comes to the speed of generation. Now, the beauty is that this is not coming from some hardware optimization. This is directly coming out of the algorithm. Now, this video is sponsored by Inception, but all of the opinions are my own. Diffusion is widely used in image and video generation, but even when it comes to text, it actually makes sense to use diffusion. Now, for this, we need to look at the nature of autoregressive models and their biggest limitation. For every next token, it needs to look at the probability of all the tokens that are available and pick the one with the highest probability. Now, it's a sequential process which is inherently slow. But there's a bigger problem. If it gets one of the tokens wrong, it cannot go back and fix it. It's like working with a typewriter where every mistake is permanent. Now, diffusion, on the other hand, starts with noise, and with every iteration, it's generating the whole sequence. So if it makes a mistake in the middle, it has the ability to modify those specific tokens. And in the process, you get much faster inference. So an example of this is going to be a text editor where you can go back in time and fix mistakes. Let me show you a few quick demos, and then I'll show you a couple of practical applications where I have found the fast inference speed to be actually useful in real world. So this is the interface we're going to be using. It has two different reasoning or thinking modes. One is instant, which disables thinking, and the second one is high, which is going to use the thinking mode. Now, on the API side, you have three different levels of thinking or reasoning efforts. You can set it to low, medium, and high. Also, this is great for agentic use cases with well-defined tasks. So if you enable web search, it can use web search as a tool, and I'll show you a couple of examples of that. Okay, so we're going to run some tests, but before that, I wanted to show you a speed comparison with other models. Now we're going to select GPT 5.2 instant because it's a similar class model. We're going to enable high reasoning effort on Mercury 2. Now the prompt that I want to try is a Tetris game, but the pieces are going up instead of down, and I want it to be in a single HTML file. So we're going to actually start GPT 5.2 instant first, and then we're going to send into Mercury 2. Now, one thing for diffusion models, time to first tokens can be relatively slower. However, it has generated the full game. GPT 5.2 instant is still writing code. Now, for certain agentic use cases, this speed of generation is going to be extremely important, especially if you want to have real-time systems. Okay, so implementation on both sides is complete. Let me actually see. This one seems to be working fine, and it started without asking me. We actually can start this. Let's see. I can control the movements of the blocks, right? Both seems to be doing exactly the same thing, but there's a huge difference in speed of generation of the code, which plays a critical role in real-time applications. But keep in mind, it's not a frontier model. This is what I would call a workhorse model. You want to use this for well-defined tasks. Okay, next we're going to test the instruction following capabilities of the model. So in this case, we are asking it to write a short story where every next sentence needs to have exactly one word longer than the previous one, and it needs to start with a 2-word sentence and continue until it gets to 20-word sentence, then reverse back down to 2 words. Okay, so this is going to be an interesting task. I will enable diffusion effect so you can actually see how the text is generated. And right now I want to test it on instant mode. Instant mode gives you very quick results. It started with 3 words, then there are 4 words, 5 words, and then I think it missed the plot. But for something like this, you want high reasoning efforts. We're going to use high, and we're going to send this again. Now, on the high reasoning effort, the time to first token is not as quick as the instant mode, but when it starts generating the response, it's pretty quick. Okay, so in this case, we start with 2 words, 3 words, 4 words, 5 words, right? And it's actually pretty coherent as well. Okay, so this is the sentence with 20 words, and then it goes down to 19. This is actually pretty impressive that it's able to not only follow the instructions, but keep the story coherent. And at the end, we get 2 words. Here is another test. We are asking it to create an HTML file with the first 25 Pokemon. I put this on instant, and we get the results instantly, although it's missing the images. Now, here's the same prompt with high reasoning effort. And with that, it gets everything right. It also added this pretty neat animation, which is pretty nice. So for any coding related tasks, I will use it on high reasoning effort, not on instant. Okay, it also has the ability to use web search tools. So let's ask it something. Why did OpenAI hire Peter Steinberg? Okay, so now it has to actually go look for different resources on the web and then give us a response. Okay, so it says OpenAI hired Peter Steinberg, the creator of open source AI agent OpenCloud, to accelerate its development of personal and multi-agent AI. So it seems like it's able to not only use the web search tool, but give us a comprehensive response on what exactly happened there. Okay, I don't think it has this in its training data, but I just disabled web search. So we're going to run this again. So it seems like the cutoff date is January 2025. And the response now is, I'm not aware of any publicly announced hiring of Peter Steinberg by OpenAI. So this is good, right? It can use the web search tool. Let me show you a couple of example applications that I have built around Mercury 2 and have found this inference speed along with its agentic and reasoning capabilities to be extremely useful. So in this example, we are looking at a voice assistant. Think of this as a customer support agent. Now, everything that is going to happen here is going to be real time. And I want you to pay close attention to the speed of text generation plus the audio generation. Can you tell me about store's working hours? Now, this is an app that I'm building where it's able to transcribe speech into text very fast. But now the rest of the backbone is powered by Mercury 2 for response generation, and then the Nova models from Cartesia for text-to-speech.
TechVault is open Monday to Friday from 9 a.m. to 8 p.m. Eastern, and Saturday and Sunday from 10 a.m. to 6 p.m. Eastern. Anything else I can help with?
This was completely real time, right? It was almost instant. What are the different products that you have in store?
We carry a range of electronics, from headphones like the Pro Wireless and Studio Monitor models. Let me know if anything catches your eye.
So you can imagine if I add voice activity detection and interruption, it can be used as a real customer support agent. Now, the second example is a retrieval augmented generation agent that is going to extract information from documents. It's my open source project that combines agentic file search with traditional semantic-based similarity search using embeddings. So let's say we're going to ask something like, what is the purchase price according to the agreement? Now, this data contains and acquisition agreement related documents. So we're going to run this. So right now you can see that the agent is able to make tool calls. So first it looked at semantic similarity, then it found a specific document. This whole thing took about 4 seconds to complete. Right. Now, this is pretty great, given that if I use other models, it can take up to 20 seconds. And it's a pretty complex system where the agent has to make multiple tool calls sequentially. Now, for the same question, Gemini 3 Flash is getting about 17 seconds in total. Now, Gemini 3 Flash is definitely a lot more capable model, but for a very well-defined use cases, Mercury 2 can be equally useful given its much faster inference speed. So think of this as a workhorse model for well-defined tasks that can use reasoning. Let's talk about benchmarks. Now I took benchmarks from the previous iteration of Mercury, and here I'm including the benchmarks that they have provided me with for Mercury 2. So they're comparing this model with models like Haiku 4.5, GPT-5 Mini, and Gemini Flash. So they're really focusing on the workhorse category of models. These are the models that you want to run constantly with well-defined tasks, and the goal is to run them at a reasonable price. This new iteration of Mercury is either state-of-the-art or close to state-of-the-art on these key benchmarks. It's designed to be used for agentic applications where reasoning can help. But the most important part of this is that now you can run Mercury 2 at 1,000 tokens per second, which aligns with the previous iterations of Mercury coder models, but now this time it's a reasoning model. Now you have autoregressive models which can go up to 1,000 tokens per second, but then you need specialized hardware like Cerebras or Grok. But Mercury's speed comes entirely from a different modeling approach. And generation speed is important, especially when it comes to time or latency sensitive applications. For a workhorse model, pricing matters a lot. This enables reasoning-based agentic use at a very competitive pricing. In fact, they have reduced the pricing from $1 per million output token to 75 cents per million output token. It has 128,000 context window, and this is the first diffusion large language model that supports reasoning. So I think it's going to be a very competitive choice for a workhorse model that you want to use in your agentic applications. Anyways, do check them out. Diffusion LLM is a new technology, but it's quickly catching up to autoregressive models. Now, is this the future? Well, the jury is still out. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.